Hi, welcome to the demo for the second project in Udacity Azure DevOps Cloud. And to do the project, firstly we have to clone Flask, start a SkyKit learn from the public Git repository and make our own application, make our own repository. And then we take the account from Azure for Azure from Udacity sandbox environment. And firstly, in first step, we generate the SSH key in order to generate SSH key to fetch code from GitHub to Azure Cloud Shell. And after we generate, we read the SSH key by this command. And next to it, we place the key in that place the SSH key part of the setting, so we can place a name here SSH key udacity to we add key and confirm the password to save the key. And after we set that, we can go back to the project and take the link with the SSH and clone the project in Azure Cloud Shell. Here is the result of clone the project, and you see it is in the Udacity 2 folder, Udacity to the project. And it contains our code of the project here. So for the first step, we create a virtual environment to run whatever we want. Create a virtual environment as my repo. And then we access to the virtual environment. Let's wait for seconds. Okay, success here. So after that, we have to run make on to install the requirements dependency and the test with hello.py file. Meanwhile, we also have to open another section for Azure Cloud Shell and access to recipe folder. And so in the next step, we will run the application here, and we will test by another section of Azure Cloud here. Oh, here it is, 10/10. Perfect score. So to run the application, we use Python app.py, and it run in the 5,000 port. And in the second section, we firstly we will see what we have in the make predict .sh. Firstly we have to we build the file. So it will call the application in port 5,000 with localhost IP, and we call predict API. So to run the file, to make sure the API work correctly in local environment, we have to change mode to file can be executed. Change for both make we change for make predict file.sh, and we'll run the sh file. And here it is. We have the result here, so it run correct with the local machine, with the local environment. So in the next step, we will create the GitHub action. We will get the GitHub action. We have to click to new workflow, and it will generate to a file, Python app YAML file, and we will replace the default code with code we provided by Azure by the lab. We replace code here, and we have to change the version of Python to 3.7 because 3.5 not work correctly recently. So after that, after we create a workflow, we will have a GitHub action run whenever we have a change in main file. We can see the build step here. It has correctly step as step defined here. So step checkout project, set up Python install dependency with make install, run pylin, run make clean and make test correctly corresponding with the step in the pipeline in the action. So in the next step, we have to create Azure web app with below command replace name web app as what we want, and we specify the group resource group as a group that we provided by the sandbox environment lab. We only have one resource group here, so we place name Azure DevOps resource group as below and run it. It takes a lot of time to create the app and start the app, so we will skip this time. And here is a result of create a web app with Azure with the command, and we can see here generate a web with sklearn with the text here, and we can make sure that the application web app we create successfully. So in the next step, we have to create a pipeline with Azure DevOps. So to do it, firstly we have to create a service connection. As the information as this step, firstly we click to new service connection. We choose Azure Resource Manager, and we select the service principal manual, select subscription level with information. What? Where? Wait a minute. Wait for load the information. We click to service principal detail, subscription ID with subscription ID, subscription name. With subscription name, we go to Azure portal and find subscription name. Yeah, let's DS 51. Service principal, perhaps application ID. Then with the service principal key, we have the secret key, and tenant ID. We have tenant ID here, and click verify. Grant all permission. Grant all permission, and we place this service connection as service connection Azure, and we click verify and save. Yeah, we have service connection Azure, and in the next step we have to get the service connection ID of this, but we cannot view anything here, so it will be accessed via another URL. Replace organization name, replace project name, and it will return a JSON file, and we find the object with the ID of the service connection. So we have the ID here. We will save the ID in this step, and we will proceed further. So next one, we go to pipeline, and we have to create a pipeline with JSON with Python default for pipeline. But I already run it. I already created. We verify GitHub. Here, and this is default pipeline. When we create a pipeline with Python, so there is some information we have to place here. First is Azure Service Connection ID is the ID we get here. We place it, and web app name and environment name. I place it the same. Web app name we have to place web app that we create before the app service. This one we have to place with this value, yeah, the same as this value, and then we validate and save. And we automatically run a new pipeline, run a new build. But to make sure, okay, a new pipeline. So to make sure it deploy another new code compared to the current web app, I will firstly stop the build, and then I make a change in the app.py file. Add pipe. I add a pipeline. So let's say, in next step we add file to git commit, update app.py file, and we push to main. We have to pull code that we changed before. Push again, and while it will run the code, it will run the pipeline automatically, because we we upload new code to Git, and we also take a lot of time to run build the code and deploy to Azure App Service. We will wait until it's success. And after a long time waiting, we have the pipeline run successfully. Firstly, it has build job, and secondly, it has the deployment job. For the build job, we check out Git, install requirement dependency in requirements.txt file, and run the test, and archive file to zip file. And in the deployment job, it will take the zip file archived by before and deploy to the web app we specify in the pipeline. So we will take this URL and place in the web browser to see that our pipeline deploy success. So with the new pipeline deploy, we access URL again, and we will see the text we newly added here for the app.py file. It proves that our pipeline deployed new code compared to the one we deployed manually with the application here, work with web app and command in Azure Cloud Shell. So next step is we compare, we call the post request to our web app by replace the app, the URL of our web app here, and we call. I already replaced it, so I will run it directly. So we call success and we return value for us. One small thing is we can view web app log. So it contains a log here, HTTP request, go to predict. And then we can go with locus. Locus is kind of simulate what we do before, but with a higher scale. We also set up a URL, set up a post request with predict endpoint, and we run the file, locus file, with this command. It will show us a website, and here it shows a lot of information like total requests per second, response time, and number of users. Yeah, a lot of charts displayed here, and that is the end of the project.